We're now going to talk about phonotactics and to use it to set the stage for our study of finite-state automata. So phonotactics are language-specific rules of what sound sequences constitute licit, that is, okay, versus illicit word forms. So here's an example. Let's take the sound sequence p, r, I, k, prick. This is a word of English. In contrast, the sound sequence p, l, I, k, plick, is not a word of English, but in principle it could be a word of English. That is, that you can think of it, it sounds intuitively as if I wanted to coin something, a new expression for a new meaning, I could easily use the word plick and you would recognize it as, okay, like that sounds like a word of English. It didn't happen to be a word of English yet by dint of historical accident, but it's definitely something that English language as a whole, in terms of the way the sound system works, is recognizable as a legitimate possible word of English. We can contrast this with the sound sequence pnick, p, n, I, k, all individual sounds of English, but when you put them together, not only is this not a word of English right now, you probably intuitively recognize that it couldn't be a word of English. It just doesn't sound right. Okay? And just to demonstrate that this is actually a very specific property of individual languages, I'm going to give you an example that demonstrates language specificity of phonotactic rules. So let's take the sound sequence z, v, u, n, zvun. I think you would agree with me that if you heard somebody try to use the word zvun to coin a word for a new meaning, new expression to label a new type of object, for example, this would feel weird. Zvun would be hard-pressed to be a word of English. However, and you can ask your native Russian speaker friends, this would be a very natural word in Russian. It actually isn't a word of Russian, but there are other very similar words of Russian. For example, zvan, is the word zvanok, which means a call, is a very natural word of Russian. So now if we dig deeper into it, the individual sounds, of course, are all part of English. So z as in zebra, v as in victory, u as in hoop, n as in can. Zvun is composed of individually English sounds, but the arrangement into this sequence is not okay in English. And it's useful now to take a moment to try to think of similar examples that maybe involve English in another language that you know, to see if you can also find examples where you can take English sound sequences, or in English sounds, arrange them in a sequence which is not okay in English, but is okay in the other language that you know, or vice versa. Take sound sequences in the language that you know, and find sounds that exist in English, but that if you arrange them into the order that into a particular order, they might not be okay in that language, but would be okay in English. What this is an example of is the fact that English sort of has what we might call more restrictive phonotactics in a lot of cases than Russian. So Russian, actually, there are many sound sequences that are okay in Russian, whereas even though the sounds exist individually in English, putting them together in the same way might not be okay in English. And languages vary very substantially in their phonotactics. So let's dig into this a little bit more. So this is a little bit of information about the basic syllable structure of English. So I'm illustrating with the word captain. So first of all, captain is a two-syllable word, and so this little sigma here is a symbol for syllable. And every syllable in phonological theory can be divided into three parts. They're built around the nucleus, which is typically, although possibly not always, a vowel. In this case, both of the nuclei in this word, the two nuclei for the two syllables, are both vowels, a and Then everything before the vowel in a syllable is the onset, and everything after the vowel in the syllable is the coda. And so syllables have the structure onset, nucleus, coda. Now, the badness of zvun has to do with the onset. It's a one-syllable, it's not a word in English, but if it were, it would be a one-syllable word. That's very clear. You probably all have that intuition. And the problem with it is the stuff that comes before the vowel, the onset. The sound sequence z, v is not okay inside the onsets of English. It is okay inside the onsets of other languages, such as Russian. So here are some more examples of prohibitions on the onsets of English. For example, sonorants, which include nasals like the sound N, liquids like the sounds L and R, can only appear at the end of an onset. So for example, net, ring, bring, and plane are all okay. So all of them have a sonorant, N, R, or L in these examples that occurs in the onset, but it's at the very end of the onset. It's the last thing that occurs before the vowel. Not okay would be examples like nzap, ruel, and lroom. All of these have, once again, a corresponding sound, which is a sonorant that is before some other consonant in the onset. So n's before z, r's before w, and l's before r. So this is one prohibition. Another prohibition is that the only fully acceptable sound that can precede a nasal or obstruent, and obstruents include stops like the sound P, fricatives like the sound Z, and affricates like the sound ch, is the sound S. So for example, spill and snout are okay. These both have obstruents at the end of the onset, and they have something before the they have obstruents or nasals before the end of the onset, and they have something before that, but the thing before it is the sound S. Not okay would be spill or znaut. And what's bad about these is that the thing that is preceding the nasal or the nasal or obstruent in the onset, is not the sound S. And you can see already that these prohibitions vary in their generality. So the first one on sonorants is a pretty broad thing. It's said about an entire class of sounds, whereas the second one is a pretty specific thing. It involves two sounds together, and one of them is only this one particular sound S. So prohibitions vary in their generality this way. Now, this gives us the lead into how should we think about the representation of knowledge that underlies this rich, tacit sort of native speaker or even non-native speaker knowledge about how onsets work in English. How should we represent that? We can take an analogy from regular expressions. So regular expressions, once again, a convenience of a lot of regular expression engines is the notion of a character class. It's a concise representation that picks out a whole class of individual specific sounds. Well, this is also done in the discipline of phonology. Phonologists write sound classes using what are called phonological features. And just a little bit about phonological features. Features are things that have generally will take on specific values for a phoneme, and for each feature, a phoneme can have a plus value, a minus value, or an unspecified value. So, for example, the feature of voicing, which is related, it's essentially the phonological, sort of symbolic, discrete version of this sort of voicing characteristic that we talked about in the difference between P and B, for example. Voiced phonemes include, for consonants, they include b, d, the, g, v, z, j, and zh. The unvoiced phonemes consist of ch, f, k, p, s, sh, t, th, and h. Now, there are some features that are generally understood to have no specification for certain sounds. So, for example, the sonorants, which include include l, m, n, ng, r, w, y. Those are the plus sonorant. All of the others are minus. But for the labials, on one analysis, b, p, f, v, m, and w are all labials. You can feel that they all use the lips, but actually none of the other phonemes are, at least on one analysis, have a labial specification. They're just unspecified for labial status. And so this is one analysis of the nature of phonemes and of the nature of phonemes using phonological features. And while the phonological features have an intuitive physiological grounding in terms of articulation, they're not the same thing. And the feature values are understood and sort of inferred in the overall scientific exercise and theory development of developing an account of how sound systems work in an individual language and across the languages of the world. Now, given that we have these phonological features, you can now think about writing phonotactic prohibitions as little regular expressions, where the phonotactic prohibitions, there are these individual feature bundles. These are widely used in phonology, and these you can think of as sort of being analogous to character classes. And the language for how you convert a feature bundle representation to a sequence as to a collection of characters is a little bit different and phonology specific, but once again, you can think about it that way. So for example, the constraint which says that it's prohibited to have a sonorant before something else in an onset, you would want to compile it down, you would want to interpret it as this regular expression where this is a character class and this is the wildcard. So you can't have mananga before any character in an onset, before anything in an onset. So the gloss of that would be that sonorants may only be onset final, and so forth. So now what we want to do is the following. Let's think of it as follows. So there are many individual constraints that can be identified in phonotactic behavior of, say, English onsets. And these, we've identified 3 of them. There are more. We can write each individual phonotactic constraint as a simple regular expression. But ultimately, what we want to describe in the mind is not one constraint or just a list of constraints, but we would actually like to have a unified representation. And sure, we could write a list of regular expressions, but that sort of raises the question, is there a unified formalism by which we can combine a set of phonotactic constraints into a unified phonotactic grammar? From a conceptual level, we might ask, well, what is it like for a native speaker to check the validity of an onset in their own mind? Do they just go through a list of individual regular expressions and see, oh, if none of them match, then it's okay, and if any of them match, then it's bad? Or is there some more holistic overall combined representation that we could describe? And it turns out that yes, there is. There's a more overall general representation that we can talk about, and the natural way to do that turns out to be through the formalism of what are called finite-state machines. And this is going to be very highly useful in phonology, but it's also going to be the launching point for us to think about other types of information and knowledge in language. And so what we're going to do next, in the next section of today's lecture, is talk about finite state machines, and ultimately we'll come back to applying them to phonotactics.